Until recently, the dream of being able to control one's environment through thoughts had been in the realm of science fiction. However, the advance of technology has brought a new reality. Today, humans can use the electrical signals corresponding to their brain activity to interact with, influence, or change their environment. The emerging field of brain-computer interface technology may allow individuals who are unable to speak or use their limbs to once again communicate or operate assistive devices, which allows them to interact with computers. We introduce to you BrainBots, an on-screen assistive keyboard that facilitates the interaction with computers and performs actions for the user using only brain signals. The keyboard uses steady-state visually evoked potential, SSVEP, which are natural responses to visual stimulation at specific frequencies. When the retina of the eye is excited by a visual stimulus, the brain generates electrical activity at the same frequency of the visual stimulus. By flashing a finite set of areas on the screens, one can determine which area was of interest to the user by comparing the frequency of the brain's electrical activity. The architecture of the system is composed of 6 main components: data acquisition, signal preprocessing, target classification, character selection, natural language processing, and assistive bots. The emotive headset is used to record the brain signals. The signal preprocessing is done by applying certain filters to remove the undesired frequency bands from the recorded signal, to prepare it for the classification process. Machine learning algorithms are used to classify the input signals and predict the target frequency. The keyboard module selects the target input character. After finishing the query, the keyboard sends the input to the NLP module. The NLP module analyzes the query to understand the user's intent. This enables the system to take the required action by running the suitable assistive bot to serve the user. The modular design of the architecture allows easily updating the back-end of any part of the system. We use a motive epoch headset to record the EEG brain signals, which are transmitted to the computer via a Bluetooth connection. The box contains the headset, a box of sensors, a USB dongle, and a USB connector for charging. The sensors must be hydrated before usage, and then plugged into the headset. So, let's see how it works. The interface consists of an input box, an output prompt, and 4 flashing boxes. Each box flashes with a different frequency. Initially, the interface shows 64 characters, divided into 4 groups. With each step, the user focuses his sight on the group containing the character that he wants to write. Using the signal recorded from his brain, the machine learning algorithm detects the desired group. Only this group remains and is divided into 4 subgroups. The user repeats the process until there is only one chosen character. As text is entered, the autocomplete module suggests the most probable words, and shows them to the user. To speed up the typing process, the user can select a suggested word, or complete the input. When the query is completed, it's sent to the NLP module, which infers the user's intent, and employs the suitable bot to carry on the command. Like translating the word hello. The user carefully wears the headset. The SSVEP signals are generated in the occipital cortex of the brain's cerebrum, which are recorded by the sensors indicated in the interface. The interface indicates the quality of the connection. Green is the best quality. Now the setup is complete, and the user is ready to use the headset. The user will try to use the on-screen keyboard. He's trying to type the sentence "Hello, dear." After the NLP module understands the user's intent, it starts one of the existing bots to perform the action asked by the user. This enables the system to act as a personal assistant. The system includes several bots. The calculator bot can evaluate any mathematical functions entered by the user, and displays the result in the output prompt. The weather bot offers weather forecast information to the user. It provides the temperature along with other conditions. The user can search Google for any subject, and easily navigates the search results. A bot which embeds another application in the keyboard's window, can also select the user interactions to easily control the application. The email bot can send emails to anyone in the contact list, or you can enter a new email address. The user is prompted to enter the subject of the email, and the body, or he can also choose a pre-saved email template. After the user submits his query, the email will be delivered to the recipient. By asking the assistant to play a certain audio or video file on his hard drive, the user can enjoy listening to his favorite music tracks or watch the latest movies. You can also translate any sentence or word to any language you want, like saying "translate thanks" to French, or you can set a default language and just say "translate thanks." The system is extensible and flexible as we provide an open-source platform to ease the creation of new bots by the community. The system shows promising results. The average target classification accuracy of the keyboard was about 92%.